Hello friends, another snow day, another video. I know there's a video online from the other teacher that you can use, but I figured I would post one myself so that maybe it just matches up better with how I normally would teach you. I don't have a choice but to kind of keep moving forward. We're already a day behind, and so this is going to be the resource for today. And then in your packet, you have a 13-2 day one worksheet. It's literally going to be adding and subtracting 360 and just kind of drawing some angles. So I think you should be okay. Tomorrow we're going to start radians, which will be tricky, but that'll give us Friday to kind of go over it again together. But I'm going to assume everybody watched this, hopefully, since that is the assigned task. So today we're talking about angles in general, like that you draw and that are not necessarily in a triangle. So understand that when you do that, this over here is always where we start. So you always start here. And then rotate accordingly. So if I rotate up a little bit, then that is the other side of my angle. And as we've been calling it, we'll call that theta. Okay. So this is just some terminology. The initial side is where it's measured from. So that would be this guy that I drew on the x-axis. And then the terminal is the end. I mean, the words say what they are. Initiate means to start. Terminate means to end. So that would be this ray right here. So where it starts and where it ends. Standard position is nothing more than what I just said, which is that it starts at that particular spot. The vertex is at the origin, which is this guy right here. So what I drew is a standard position angle. If you go in the direction that I went, like you head counterclockwise up, that's going to be a positive theta. If you start from that same starting spot, because you always have to, and you head downward instead in a clockwise direction, that's going to be indicated as negative. And that is going to be the thing that's probably the trickiest. So you're going to need to practice that, is my guess. Okay, so that's notated here. Coterminals, and that's really what we're going to be practicing down in the chart, and the majority of this is like the majority of this assignment. Basically, again, the word tells you what it is. Co is shared, terminal is ending. So they have a shared ending. And what that means to me is that they stop in the same place. Now, we're treating this almost like a dial, like hands on a clock, so that that ray that you're making your angle with can go around and around and around. So the fact that it creates a circle means that coterminal angles are one trip around the circle away from each other. And for today, we're still measuring that in the common measurement of degrees. And so that's 360. You can see a little foreshadowing here. We're going to start talking about radians. It's a really important element for all the math from now on. And so that's just something that we have to start getting into our brains. Just a quick reminder for the quadrants, because I sometimes talk about what quadrant it is in. The different quadrants, they're numbered with Roman numerals, and they go 1, 2, 3, 4 in that order, just to kind of remind you. Okay, so there's two main things you're doing today. Drawing angles in standard position, which is going to look like a bunch of spirals, and also finding coterminal angles, which you find by taking your angle and adding and subtracting trips around the circle. That is the entire thing. So you'll want your calculator, but it's super easy. Good snow day activity. Okay, so here we're going to do what it says. We're going to draw an angle in standard position. You have to draw it accurately, and then find one positive and one negative coterminal, which we will do by taking the angle they gave us and adding and subtracting 360 to get those positive and negative options for other angles that would stop in the same place. So these three things kind of all go together. Here's our angle, and then we're going to find a positive and a negative coterminal. So our first order of business is to draw it. Keep in mind that this is 0. It's also all the way around, so 360. This top is 90. This is 180, and the bottom is 270 if you're going in that counterclockwise positive direction. So at 65, you want to be fairly accurate, and you want to draw it like closer to 90 than not, because that's where 65 would be. And so then you draw a little arrow here to indicate the direction that you went, and that is going to be your 65-degree angle. That's it. That's the drawing. Super easy. It gets harder as they're negative or really big, but that's the beginning of it. And so then for coterminals, we literally are adding or subtracting trips around the circle. This one has to be positive, so I can't subtract 360. So I have to add one trip around the circle. And when I do, I end up at 425 degrees, and that is considered coterminal. If I drew that one, and I'll draw that in a different color so you can see it, I would go all the way around once and then follow this other angle to the same spot. So ultimately they stop in the same place. The only difference is the spiral indicates that this angle, the 425, went around once, so that's 360, plus that additional 65. Okay, so if I need a negative one, I'm going to need to subtract 360 from my 65. So if I do that, I get another coterminal, which is at negative 295 degrees. Okay, so let's just draw that. You're not going to have to draw these all the time. I'm just kind of showing you. That would mean that I would start at 0, but I would go around. I'm trying to figure out where I can cram this in. I would start at 0. I would go in an, negative direction. Trying to erase that without erasing my whole entire picture. I would go down, so that's negative 90, negative 180, negative 270, and then to negative 295. So I'm going to the same place, thus coterminal, but that is negative 295 degrees to get there. And notice that 295 and 65 add up to 360 because going this direction, 65, and going the other direction, 295, should be the whole circle. That's how they meet. Now, what you're really responsible for drawing in the homework is just the original angle, not the coterminals. So let's just do that from now on. So in the second example, it's negative. So when I go to think about how far I should go, I think, okay, this is still 0 no matter what, but now I'm going this way. So my 90 would be here and my 180 would be here. So 105 is going to sneak in just a smidge. It's got to start here. That's my initial side. And it's going to sneak in just kind of a smidge past 90 because it's only 15 degrees past it. And then I draw that little curve to show that, hey, this is my negative 105 degree angle. And it's going counterclockwise because it's negative. Here to get a positive coterminal, I'd have to add 360 because subtracting would just make it more negative. And I'd end up at 255, which means if I had started up here and gone in a positive direction, I would go 255 to get to the same spot. If I need another negative in this case, I can just take away one more trip around, and then that would require me to be more than one trip around the circle. So if I did draw that, it would be a spiral again. Okay, so the next one's different in that it's positive, but it's a really big number. It's more than 360. So let's walk through that one together. So 480 degrees. Okay, keeping in mind that all the way around is going to be 360. So think about it. 480 minus one trip around is going to land me at 120. So I still need to go 120 more. So if I go and I'm going in the positive, so up direction, all the way around, creates the first loop of my spiral and burns up my 360 degrees. Now I still have to go 120, which is going to mean 30 past 90, so somewhere around there. And so then this will be the terminal side of my angle over there. And that spiral is what indicates that you went around more than just one time. And I went 30 degrees past 90 because of this residual 120. Now, when it comes to doing the coterminals, since that initial number was so big, I can just take away the 360 like I already had to do to graph it, and I still end up with a positive coterminal because it was so big. So don't just get in your brain that I always add 360 for the positive and subtract 360. If it's a really huge number, you subtract 360, it's still a positive number. And then what I would do is subtract 360 a second time, because you can go around the circle as many times as you need to. And I would subtract it a second time so that I get a negative version of that angle. So again, up in my original picture, that would mean I could go this way, 240, and I'd end up in the same exact spot. They're just different ways of writing the exact same thing. Okay, and the grand finale. See, this isn't so terrible. In this last one, which is definitely feeling red, this one's double tricky because it's negative and it's way more than one trip around the circle. So let's start off with negative 765. Let's add one trip around the circle. And I'm adding because I need to get towards a positive. So when I add that the first time, I get negative 405. So that's going to be one trip. But keep in mind, I'm going in the negative direction. So one trip around so far. Then I need to add another trip because I haven't gotten to a place where I can graph, where I can graph the end yet. So when I add another trip around, now I'm at negative 45. So I have to go around one more time. Oopsies, pick up where I left off. And go around one more time. So that takes care of this trip around and this trip around, both in that negative direction. And then I would have to add 360 again to finally get to a positive answer, which is 315. So starting at the very beginning, I'm going to actually start my spiral over so you can see me doing it in all at one time. I need to go around 3 times. So I'm going to go once, 2 times, that's 720. And then I still have to go 45 more. And so that's going to put me here. And that's where that negative 45 is. Because that would be going down 45 degrees. Or I could have gone this positive 315. So these last two actually turn out to be my answers from up for the chart, because I have to figure out how many times around I'm going anyway. So I go down here and I'm thinking, okay, I started at negative 765 and then I did all this work. And the first positive answer I got to was 315 because I kept adding trips around the circle until I got a positive number. And then for the negative ones, you could use any of the negative numbers you came up with along the way by adding the 360. The first time we added 360, we got negative 405. That would be considered coterminal. We added another trip and got negative 45. So those both work because they're both negative and they're both one trip around the circle, meaning you got them by adding or subtracting 360. So either of these would work. So I think this last one's kind of tricky. There aren't a ton like that on your worksheet. So let's just quick look at the worksheet that you're working on. So where's my homework packet? Right here. I'm going to 13 to day 1. And the whole front is just drawing. So I'm going to go, okay, like here, negative 10. I always start here. And if I'm going negative, this is negative 90. I'm only going a hair towards that. So then I draw my little kind of spiral, even though this one doesn't go very far, and show that that's negative 10 degrees. That's all I'm doing on the front. So down here, number 10, 235. Okay, that's positive. So here's my initial side at 0. Here's 90. Here's 180. Here's 270. So I need to land in that third quadrant between 180 and 270. And so if you're looking at 270, 235 is only 35 away from that. So I'm going to go to about here. So I'm passing 90, I'm passing 180, and I'm going all the way over here to 235, which is just 35. This part over here is just 35 away from 270. So I want to be closer to that. So the whole front page is just drawing accurately. Here's where we have to find one positive and one negative. So if the number is like negative, like in number 13, having a little struggle here getting this to zoom out. here I would start by adding 360 because it's already negative. So negative 210, I'd add 360, and 150 would end in the same spot. And then I also would have to subtract 360 from that negative 210. So negative 210 minus 360 to give me another negative version, which would be negative 570. So you're literally just adding and subtracting. Then from here on down, this is review of SOHCAHTOA. So for example here, draw yourself a triangle, put an angle in here, and then label. Across from it will be opposite. The long one across from the 90 will be hypotenuse, and this guy will be the adjacent. Since this is sine, it's the SO part, meaning this is opposite over hypotenuse. So I go to my drawing and I say, okay, 9 is the opposite side, 41 is the hypotenuse side. I don't know this, so I'm going to use Pythagorean theorem. And then I'm going to take 41 squared minus 9 squared. So I'm moving this over here. And I'm getting 1600. And I'm going to see if that's a perfect square. It is a perfect square of 40. So that means this side is 40. So these are my three opposite, adjacent, and hypotenuse numbers. So over here where it's asking for cosine, I think, okay, cosine is adjacent over hypotenuse. So I go to my picture, adjacent is 40, hypotenuse 41. And that does not reduce. Tangent, opposite over adjacent, so I go to my picture. Opposite is 9, adjacent is 40, that does not reduce. So the rest of these are just review of that SOHCAHTOA. So knock it out of the park because unfortunately, I'm not going to go back and reteach all of this when we are in school because we don't have that kind of time. So just use the video and then use your big brain and knock this out. You know there's a key online, but make sure you're just confirming, not copying, because when we have a quiz on it, you want to know what you're doing. And then go outside and play in the snow. See you soon, guys. Bye.